Hello, this is Mr. Stewart bringing you the 5.3 5.4 homework quiz all about proportions. This time we're actually using the same idea from 5.2 about proportionality, but we're taking it one step further and asking you to find an unknown section of the proportional relationship. So as a quick review, I'm going to give you this example right here. In 5.2, we learned that two ratios form a proportion if they're equivalent to each other. We can check for proportionality by using the cross product method. So in other words, if 2 times 4, which happens to be 8, is equal to 1 times 8, which does happen to be equal to 8, then that means that they form a proportion. We say these are proportional. Okay, I'm just going to abbreviate it. Taking a look at this example, I know you already know what n is equal to, but the point is to help you understand how we can check to see, or how we can actually solve for n. This is going to feel very familiar to you because in Unit 2 we set up equations and solved for unknowns by doing the inverse operation. So we're going to talk about that a little bit as well today. But for now, you can use the cross product method to help solve for n. We know how to do this. So we could do 2 times n. Now remember, 2 times n is just equal to 2n. That's the same thing. We can also do this, 1 times 8. And we know that 1 times 8 is equal to 8. Well, now take a look at this. We know that 8 on the left is equal to 2n on the right. So we just brought everything down. And this has just become an equation that is probably very easy for most people to solve. Identify where the variable is. It's here on the right. And so I remember that 2 next to a variable is just multiplication. I undo this operation by doing the inverse of that operation, or in other words, division. If I divide both sides by 2 to keep it balanced, that's going to cancel the 2 divided by 2 out because that goes to 1. N is left alone, so I bring it down, and I calculate over here, what is 8 divided by 2? Well, 8 divided by 2 is 4. I bring down the equal sign, and I get that n is equal to 4. So in my example, I could say n is equal to 4. If I substitute that back in, it indeed forms a proportion, making these two ratios equivalent to each other, completing the equation that makes it true. I want you to understand something. When I set up an equation like this, I'm going to do the exact same thing. I can make it a little more simple for myself. If you want to make things simple for yourself, now's a really good time to pay attention. I look at this variable here and I just think to myself, I need to isolate this variable by doing the inverse operation of the number that's happening to that variable. Well, what's happening to this variable? It's being divided by 8. How do I undo division? Well, I multiply both sides by 8. Do you see why we spent so much time in Unit 2, equations and inequalities? Because everything you do for the rest of the year is going to require you to have a basic knowledge of equations. If I multiply both sides by 8, that's going to cancel this out because 8 times n over 8 times 1 is just going to be 8n over 8, and the two 8's will cancel out. Then I do the multiplication over here, and this is going to become 8 times 1 over 2, because that's just 8 over 1, and that's going to be equal to n. Well, we can reduce this down. What is 8 over 2 reduced to 4 over 1, or just 4? Or we can just think, how many times does 2 go into 8? 4 times. So in other words, I get n is equal to 4. A few less steps if you do it this way. Is all I'm saying is use the equations, or use your knowledge of equations to help you solve for proportional unknowns, It's just the same as a single step equation. Sometimes you'll be given tables and graphs and charts, and you'll be asked to interpret the data and then set them up in proportional relationships. Well, I'm going to do the same thing. Meters per second. In race 1, something or someone went 40 meters in 10 seconds. Who knows? In race 2, something or someone went 100 meters in S amount of seconds? We don't know. So we don't know how many seconds that was. We are going to assume that they are proportional to each other, and if that's the case, then we would be able to find the unknown. So I'm just helping you set this up. I'm not going to solve this one for you, but you can use cross multiplication and then solve for S by doing inverse operations, solving for equations. Again, this is just more of the same, just asking you to write the answer in the blank instead. So what is B equal to? When the variable is in the denominator, like question 2 and 3, I think the best thing to do would be to use cross multiplication, and you would get yourself B times 7.2 is equal to 10.8 times 8.4. But I do want you to understand that as long as these two ratios are proportional to each other, I can flip things around and keep things and be able to work with that as well. So I could rewrite this ratio as 8 and 4/10 over 7.2. Notice what I did is I just flipped them. And if I do that, and I want to keep it proportional, then I just flip this as well and do B over 10.8. So you can work with either one of these. They're the same ratio. Well, I shouldn't say. I need to be careful with this. This ratio is not necessarily the same as this ratio, but as long as they got flipped at the same time, the proportionality remains. And if the proportionality remains, that'll allow us to still be able to solve for B. So use whatever method you want, but it's at this point, pretty simple. You just need to undo the operation of B times 7.2. Okay. The last question is a nice little word problem. I'll read this out loud. It reads, a person who weighs 90 pounds on Earth weighs 6 pounds on Pluto. Now it reads, how much does a person weigh on Earth if a person would weigh 10 pounds on Pluto? So if we could ever get a human being to stand on Pluto, the weight that you would feel would make you feel like you're 6 pounds, which would be incredible. So you're going to use this information to help you set up rates, ratios. And remember, it's important to keep units of measurement proportional to one another. So if the weight for Earth is in the numerator, then both weights for Earth should be in the numerator. Let me show you what I mean. Let's say 90, I'm going to call it Earth pounds, because that's really all that means to us. Is pounds is just what is calculated for the gravity of Earth, and that's over. Let's see. You could say that's this is a ratio of 90 Earth pounds to 6 Pluto pounds. You could do it this way. There's actually other ways to set this up, but I'm going to set it up this way. 90 Earth pounds to 6 Pluto pounds. We want to set this equal to, the question is, we don't know how much a person would weigh if they weighed 10 pounds on Pluto. It's a super weird question to ask, but, mathematicians don't really care about weird questions. We just do the math, right? So we want to know what this would be in Earth pounds compared to 10 Pluto pounds. Okay. Well, this is a proportional relationship. Right? If scientists are correct, then we could find the unknown variable of Earth pounds if given the Pluto pounds using this piece of information, because the proportionality is going to be maintained even if you travel a far distance away. So hopefully this idea was set up for you in a way that makes sense. You know, I will just tell you quickly, you could have set it up like this. 90 Earth pounds is the same as 6 Pluto pounds. And so what would that be if we were working with 10 Pluto pounds? How many Earth pounds? You could set it up this way as well. You're going to find the same answer either way. So as long as you're sort of setting it up in a proportional relationship where one makes sense with the other, you can do it this way. But to keep things nice and organized, I typically like to keep the same units of measurement in the same section. Hopefully this is helpful for you, and hopefully you're able to get a higher score on the quiz because of this video. If you have any further questions, go ask somebody else. Have a great day, and don't forget to be awesome.